The discovery made by scientists brings us closer than ever to a day when humans can open portals and travel to other dimensions. This groundbreaking finding is considered the most significant of the century, and it holds the potential to answer the age-old question of whether we are alone in the universe. Scientists have developed a technology capable of achieving interstellar teleportation, and in this journey, we will delve into how they accomplished this feat and where these portals will lead us. While it may seem that instant travel between worlds is beyond the reach of our current advanced spatial technologies, scientists are actively working to break down this barrier. Science fiction movies like Star Trek and Marvel's Avengers have tantalized us with the idea of phasing technology and warp drives on advanced alien spaceships, pushing the boundaries of our imagination. However, these stories didn't stop at mere speculation. They also delved into the concept of interdimensional travel or teleportation. Although teleportation seems virtually impossible even on paper, as it would require a technological doorway to transport us instantly while keeping our mind, body, and soul intact, scientists have devised a two-stage technology for achieving teleportation. Teleportation, or the opening of portals for interdimensional travel, cannot be likened to an organic fax machine, as it involves the intricate process of physically deconstructing the body at one point and reconstituting it at another point in the desired destination. This deconstruction phase converts the person's body into data, which is then transmitted through the portal and transformed back into matter. A significant milestone in the exploration of interstellar travel through portals can be observed in the Chinese Space Agency's successful teleportation of photons over a distance of 300 miles to a satellite in orbit. This achievement relied on the phenomenon of quantum entanglement, a process initially proposed by Albert Einstein. Quantum entanglement fascinated Einstein as he observed that a pair of photons could change their states simultaneously, even when separated by a great distance without any apparent connection between them. The implications of quantum entanglement extend beyond photon teleportation and hold potential for the study of antimatter and subatomic particles. Applied quantum entanglement could provide insights into transferring information from one energy pole to another in different times and spaces. However, if we were to explore the transmission of atoms and molecules across dimensions, the sheer magnitude of atoms involved would be immense. A single bacterium, for instance, may consist of approximately 9 to the power of 10 atoms, which is the average number found in a single cell. Considering the human body, which comprises 32 trillion cells, the number of atoms to be transmitted surpasses the count of stars in our universe. Achieving the teleportation of humans would require the meticulous breakdown of every cell, and the computational power necessary to analyze such a feat would be immense. It is estimated that more than 10 trillion gigawatts of power would be required, equivalent to the entire power supply of the United Kingdom. A group of scientists at the European Centre for Nuclear Research, CERN, has made significant progress in accessing a subatomic level portal through their advanced cosmic gun. In their groundbreaking project, they have observed a previously unseen parallel, albeit with a thin plot. This development raises the possibility that their man-made machine could eventually allow us to explore the fundamental fabric of the universe, contributing to our understanding of the world around us. In the near future, navigating an alternate universe through a rupture in the space-time continuum may become a reality by harnessing the power of black holes and wormholes. CERN's colossal particle accelerators have sparked discussions on how scientific experiments can aid in unlocking the universe's secrets. One such revolutionary technology is the Hadron Collider, an immensely powerful atom smasher. The Hadron Collider, considered the world's most potent particle accelerator, consists of a complex arrangement of superconducting magnets designed to surpass the limits of particle physics. By utilizing this accelerator, scientists can explore the mysteries of dark matter and energy, investigate the scarcity of antimatter in the universe, and delve into the unique composition of the cosmos. This exploration holds the potential to uncover previously unknown particles, expanding the frontiers of scientific knowledge. Scientists have made significant progress in understanding the complex nature of our universe, evident when they recently discovered 3 previously unknown particles. This groundbreaking research, supported by the collaborative efforts of researchers from the University of California, Berkeley and the University of Wisconsin-Madison, suggests that the characteristics of these particles can provide insights into the structure and form of additional spatial dimensions that adhere to the principles of string theory. String theory, which serves as the basis for this investigation, proposes that the fundamental particles composing the universe are dynamic energy strings that vibrate continuously. This notion implies the existence of 6 to 7 spatial dimensions beyond the 3 dimensions we are familiar with, along with time. These additional dimensions, each exhibiting distinct shapes, play a crucial role in determining the behavior of our 4-dimensional universe and its observable properties. Gary Hsu, a physics professor at the University of Wisconsin-Madison, highlighted the significance of dimension shapes in string theory. According to Hsu, the manner in which the strings vibrate directly influences the masses of particles and the forces they exert. By focusing on understanding the shapes of these dimensions, we can predict the structure of our 4-dimensional world and gain insights into its inner properties. The additional dimensions can assume various shapes, and it is crucial to distinguish between different particles within them. To streamline the possibilities and identify the more plausible options, researchers propose using experimental data, which could potentially be obtained from a particle accelerator like the Large Hadron Collider. Understanding the components and structure of particles through the Large Hadron Collider would empower scientists to replicate or manipulate them for the betterment of humanity. However, some individuals fear that this research could lead us perilously close to the metaphorical gates of hell. The concern arises from the notion that tampering with these relatively unknown subatomic particles at the speed of light could inadvertently open dreadful portals, posing a threat to human existence. Nevertheless, it is important to note that many of these apprehensions are rooted in conspiracy theories entwined with spiritual sentiments. CERN, on the other hand, has a distinct objective that speaks for itself. By harnessing the unique properties of exotic particles, such as antimatter, CERN aims to explore the nature of matter, mass, and their potential application in transversal movement within specific spaces. Subatomic particles, including antimatter, possess a reverse charge compared to regular matter. This fact holds significance for avid believers in the Big Bang Theory, who suggest that a substantial amount of antimatter was created during the formation of the universe. However, the notion that antimatter is as abundant as matter itself is debunked by the inherent scarcity of antimatter particles in everyday life. Now, the question arises, could utilizing the Hadron Collider to generate subatomic particles create a rift in reality, disturbing the delicate balance of the visible world? If such an event were even possible, it could result in people experiencing the dreams and lives of their alternative selves, as portrayed in Marvel's Multiverse of Madness. However, this hypothetical scenario would not be caused by magical powers but rather by damage to the fabric of reality resulting from the collision of particles that uphold the structure of the universe. The emergence of these particles into our reality has the potential to trigger what is commonly known as the Mandela effect. This peculiar phenomenon manifests when numerous individuals consistently recall past events occurring differently from their actual historical record. The unsettling nature of this effect could manifest within the confined space of the laboratory conducting the experiment or on a larger scale. The impact resulting from the unstable particles discovered by the Hadron Collider will depend on the extent of the damage they can inflict. A single particle might carry an astonishing charge of up to 125 billion volts, and particles with such magnitude can disrupt the established laws of physics governing our world. However, it is important to dispel these conspiratorial concerns as they lack foundation. The operation of the Large Hadron Collider will not create a rupture in the fabric of reality, nor will it alter normal time and space. The discovery of these particles signifies a significant advancement in our understanding of the profound mysteries that the universe holds. The ongoing project has recently entered a pause phase to undergo necessary upgrades aimed at enhancing the accuracy and overall efficiency of the particle accelerator. Once it resumes its research, we anticipate even greater scientific progress. While this news might disappoint those eagerly awaiting immediate breakthroughs, the quest to open a portal to another dimension is closer than ever before. We are merely one step away from this monumental achievement. Please share your thoughts on this matter in the comments section below.